Hi everyone, in this video we are going to break down an efficient algorithm to solve the problem of merging k-sorted linked list into one sorted linked list. This is a common question in coding interviews and I'll explain it step by step. Imagine you're given an array of k linked lists, each of which is sorted in ascending order. Our task is to merge all these linked lists into a single sorted linked list and return it. For example, if the input is three lists, one contains the elements 1, 4, and 5, and the second list contains the elements 1, 3, and 4, and the third list contains the elements 2 and 6. The output should be 1, 1, 2, 3, 4, 4, 5, 6. Let me just write it here in the comments. Here, yeah, I think it's given here. You can see it right there, so I don't have to write it. You can see the example here. And so to solve this problem, we will use divide and conquer approach, which efficiently merges the list step by step. The idea is to repeatedly divide the array of linked lists into smaller parts, merge them, and combine the results. Let's walk through the code to see how this works. First, I'm going to write a method to merge two lists. So in this method, we take two sorted linked lists and merges them into one. This is a classic merge operation. If one list is empty, we return the other list. Otherwise, we compare the heads of the two lists and recursively set the next pointer of the smaller node to the result of merging the remaining parts. This ensures the resulting list remains sorted. So let me write this method first. So yeah, first I'm going to write this method here, public list node merge two lists. List node L1, comma, list node L2. As I said, if L1 is equal to null, return L2. And if L2 is equal to null, return L1. If the value that is pointing to the head of the L1 is less than the value from the list node L2 where the head is pointing to. We need to make the comparisons here. Then we say that L1.nest is the pointer is equal to merge to list. Here we are making a recursive call L1.nest comma L2. Return L1 else again a recursive call, but this time it's L1 and L2.nest. So here in this recursive merge, as you can see here we are comparing the value of the heads of the two lists. So if L1.val is smaller, then set L1.nest is equal to the result of the merging L1.nest comma L2. Otherwise, we set L2.nest is equal to the result of merging L1 and L2.nest. So, and it would return the smaller head node L1 or L2, whichever is smaller. Now we have the method to merge two lists. We can very well write the method that merges k lists. So here we already have the signature for the method here. So I'm gonna say if list.length equal to 0, return null, return here in this method. As you can see, the first line is about the edge case. If the input list is empty, return null. And we are calling the divide and conquer method here with a full range of indices in the list array. And now we need to write the divide and conquer method. I'm going to write it right here. if left is equal to right, return list left. So here this is a recursive method again, and this divides the problem of merging k list into smaller subproblems. The base case, you can see that if the left is equal to the right, it means there's only one list in the range, and so we return that list. And then we compute the midpoint. The midpoint would be left plus right minus left divided by 2. And then we recursively divide the range into two halves. Merge the left half to the mid and merge the right half, mid plus 1 to the right. And then conquer, merge the results of the two halves using merge to list method. So I'm going to give an example here. Let's say I'm going to talk about the flow, execution flow here. Let's take this example. This is the list that we have 1, 4, 5, and then 1, 3, 4, and 2, 6. So first, the initial call would be merge k list, and so as you can see, this calls the divide and conquer method. So the input would be list, and 0 is the first element in an array, and list length minus 1. Here the length is 3, and length minus 1 would be 2. So here you say 2, and then the first level of division. So now we are in this method. As we are in this method, we calculate the midpoint. The midpoint would be, of course, the midpoint would be 1, and split it into 2 halves. So as you can see here, the left and the right. So let's take this one. Okay, so this would be the left. List 0. Left is, it starts with 0 for now, and then midpoint is 1. So mid plus 1 is 2, and the rightmost is 2. That's the last index of the last element in the array, in the list, and in the array actually. So now what do? We have this again, we call it recursively, right? So we call divide and conquer. We go into this one and explain what's happening here. Here the midpoint is, mid would be 0 here. Between 0 and 1 it's gonna be 0, and let's calculate the left and the right here. So left is gonna be 0 and 0, the mid is 0 too, and that's gonna return 0. So here we know that the list of 0 is this one. The list at the index 0, that's that one. So that would be returned, and here this is gonna return list 1. So the element at at index 1 of the list array is gonna be this one. Now we are gonna conquer the right half. We are gonna say, we're gonna take this one, and that's gonna return the element at the index 2, which is gonna be this one, the last element. So for the final merge, and I'm sorry, I forgot to tell this one here. So when we return the left and the right, we have to also merge these two. Using merge to list, and the result would be and now the final step, final merge would be we are going to merge this one here and this one here. So using merge to list, and it's gonna return the result, which is going to be and if now let's talk about the time complexity analysis. The merge to list method, yeah, where is it? Here, right here. It takes O of n, where n is the combined length of the two lists, and the divide and conquer method here, it at each level of recursion, every pair of list is merged. So the total number of levels log k, since the number of list is halved at each level. So at each level, all n elements are processed. So the overall time complexity for would be O of n log k, where n is the total number of elements across all lists and k is the number of the linked list. And this code is efficient because the divide and conquer approach, it reduces the number of mergers required compared to merging the list sequentially. This makes the solution significantly faster for large values of k and n. Thank you for watching. I'll see you in the next video.